Hi there folks, today we're looking not at the averages, the numbers right in the middle, but how spread out our data is. You should remember quartiles, the interquartile range, things like that from GCSE, and you would have done things like box and whisker diagrams where you would have had something looking like this. And hopefully you remember that this would be the lower bound, the smallest value, this would be the upper bound, the biggest value, so your range would be all of that. You have your interquartile range between here and here. So your lower quartile, your smallest amount, your 1/4 of the way through your data would be there, 3/4 of the way through would be there, and this here, between the lower and the upper quartile, would be your most typical half, which is really, really important. Today we're also going to bring in, as well as quartiles, finding percentiles. So if you had the 10th percentile, that would be 10 out of 100 and stuff like that. But before we do, you'll notice I've got a bunch of stuff written down here in blue, and the way that we find the quartile is just slightly different to what you were probably told at GCSE. So I recommend you pause the video and have a little read of that whilst I get some data together so that I can demonstrate what that means. So here's our set of data from the large data set, but that doesn't really matter. The important thing is we've got 20 numbers. Now if I want to know what the median is, what you would have been told before is n plus 1 divided by 2. How many data points I've got, divide by 2. The only thing is, when it comes to quartiles, sometimes you'll get 0.25, so where do you go? Which is why we have this subtle change. So I've got 20 days, so 20 divided by 2 is 10 exactly. So that means because it's a whole number, I then go to 10.5. I go to halfway between that and the next one. So there's my 10th, there's my 11th, so halfway between 22 and 23, so it's 22 plus 23 over 2, which is 22.5. Now of course that is knots, isn't it? Because we've got units. Then if you were asked for the quartiles, the lower quartile will be, if we do 20 divided by 4, that is 5. So 1, 2, 3, 4, 5. We don't take that one, we take halfway between this one and the next one up. Now that's because if you added 1 to 21, you get 21.25, which would be a little bit confusing, wouldn't it? So anyway, we go to 5, we go, so halfway between those two, and they're both 18, so it's 18 knots. If we want the upper quartile, it's sometimes called Q3, by the way. Q1 is the lower quartile. Q2 is the median, because 2/4 make a half, and Q3 is the upper quartile. Upper quartile. So we want 3/4 of 20 this time, which is 15. So then it's going to be between the 15th and 16th values. So it takes a little bit of getting used to, but it's basically the same thing. So we've got 10, 11, 12, 13, 14, 15 and 16. So we're going halfway between those two. So 25 plus 26 over 2 gives us 25.5 knots. Okay, and we're ready to move on to percentiles. And also interpolation, because we're going to be looking now next not at nice whole numbers, discrete data, but at continuous data, and what happens when we've got grouped data in continuous form, which is what most data is going to be, because all of these things will have been recorded, and anything that's recorded can be finer measured, and therefore it's going to be continuous data. So, as promised, some data this time. This is about how long students are spending on the internet in a given time. So they're all amazingly between 30 and 40 minutes, aren't they? Or exactly how long is this? And this is an important thing. Before we get anywhere, the first thing we're going to do is estimate the upper quartile. So that is where we are coming 3/4 of the way through. Now we don't have to do anything fancy about finding 3/4 of how many we've got and then rounding up, because it's an estimate and all of our data is all a bit of a mystery anyway. We can just go with 1/4 of however many we've got. So if we add up 2, 25 is 27, 57, 67, we've got 70 people all together. So the upper quartile is going to be at 3/4 of 70, which is 52.5. And we do not need to worry about the fact that it's a nonsense to have half a person. It's just halfway through wherever they would be predicted to be. So we want that. Now if we look here, we've got 2 people there, we've got 2 plus 25 makes 27 there, plus 30 makes 57. So I know that the 52.5th person is going to be in here somewhere. How far in there? Well, if I take 27 away from 52.5, I get 25.5. So it's 25.5 as a fraction. The size of this group is 30, so I want 25.5 out of those 30 people, and then I want that to be in this time zone. Now it might look like that time zone's 2 minutes, but look at it carefully. This has all been rounded to the nearest minute, and what have we got? Well, what is the true boundary here? Is it 33? Is it 34? Can't be either, can it? It's got to be 33.5 would be our boundary point there, and 36.5 would be our boundary point there. So what's the actual group width we've got here? From 33.5 to 36.5 is 3. So I want that far of a fraction through 3 of 3, and when I've worked that out, I want to add it to, because I want this as an estimate of time, it's going to be that much bigger than 33.5, because this is going to give me a number that's nearly 3. Add it onto 33.5 will get me through to there. So I'm going to put that in brackets and write add 33.5, and then I'm going to pop that little lot into the calculator. Open brackets, put in 25.5 over 30, and with the wonders of editing, that's gone straight through, put it all in there, and has given us 36.05 minutes as being our upper quartile. Now that's nice. How about the 10th percentile? The 10th percentile is just the same idea. We've got 70 people. 10% of 70 equals 7. So I want the 7th person in here. Now I've got 2 people there. 5 more gets me to 7. So I want 5 out of the 25 that are there. So that's 1/5, isn't it? Times, what's this group width? That's going from 31.5 up to 33.5. Well, that's only 2 that time. So I want 1/5 of 2, which we kind of know is 0.4, but anyway, hold with it. And I'm going to add that to my starting point for this group width, which is 31.5. So I'm not going to try and be too clever, even though I was sort of working out as I went there. I'm just going to whack it all in there and see what that comes out with. And it comes out with 31.9 minutes. And that's our 10th percentile. Right, now I hope that made a bit of sense. If not, don't worry, because we've got time to practice 2 or 3 more of them now. Right, so we're going to do two questions actually. This is the first. Pause the video, give it a go, and then we'll talk through what you should have got. So first up, timesing the midpoints by all of the frequencies and then dividing by how many you've got, which if you add those frequencies up is 49. You get 43.97 minutes, so rounding to three significant figures is 44.0. Right, I'll talk through the calculating 65th percentile, so make sure you've done it. So 65, if I do 0.65 times 49, that's probably going to give me something nasty. That gives me 31.85. So I want the 31.85 through here in terms of the frequency. So I get to 16 there, add another 18, I get to 34. So I know it's somewhere in here. So I take away the 16 that aren't in there, and that gives me 15.85. That's how far into this load of 18 that I want it to be. So I'm going to be doing 15.85 out of 18 multiplied by the group width. Now this time we don't have to add a half on, because if you look carefully, the boundary is at 40, is at 50. So it is just 10. And then we're going to add that to the start point of this group, which is 40. Do all of that and you should get 48.80. So that's 48.8 minutes, isn't it? To three significant figures. And then the last part, once again, make sure you've had a go at it. The firm writes the following statement: only 10% of our customers have to wait longer than 56 minutes. So we need to know the 90th percentile, because 100% take 10% is 90%. So first of all, 0.9 times the 49 gives us 44.1. So we want along here, that's 34 to there, plus 13 would get you to 47. So it's in this group here. Take 34 away and I can see that's going to be 10.1. So we're going to want 10.1 out of the 13 that are in that group, times by the width, which is 10, and add it to the start point, which is 50, and that should give you 57.76 or 57.8. So we've calculated a suitable percentile, which is 90th, and now that's longer. So comment on the validity. The claim is invalid because 10% wait longer than 57.8 minutes, which is longer than 56. Finally, time to sort out the Californian condors. We've been waiting for this. Right, have a little look at it, pause the video, give it a go. So estimating the 80th percentile, we're going to want 0.8 for our 80% times how many we've got. Well, they've already told us 100, so we want the 80th. Right, 4 plus 20 is 24, plus 37 is 71, sorry, 61, plus 28 is 89. So it's in here somewhere, isn't it? So 80, 80 take 61 is 19, so having trouble with my adding, is 19. So we want 19/28ths of, those are the true boundaries, so it's just going up 0.5. It doesn't sound like much, but it is half a metre of wingspan on a condor, so it's actually quite a lot. 0.5, and we're going to add that to the smallest wingspan in the group, which is 2.5. Put all of that in there and you should get 2.839 or 2.84 to 3 significant figures, and interpret the value. That means that is the, we're saying that 80% of condors have a wingspan of less than 2.84 meters, which is not surprising because that's blinking big. Right, finally, just a quick one for 1 mark. State why it's not possible to estimate the 90th percentile. Well, the 90th value is in there, isn't it? And this, oh, what's the top end? The top end isn't there at all. Now, you're never going to get a condor that's got an infinitely large wingspan, but they haven't told us what the biggest wingspan is. Therefore, it's not possible because we don't have a data point there to talk about. So that would be why, because that we have not got an end to that that class. Right, folks, I hope you enjoyed that. Next week we will start to have a little look at what we next do with quartiles and percentiles, which I did hint at the very beginning when I used the word range. So we're going to look at how we use interquartile ranges, and we can also have percentile ranges too. So see you then. Bye bye.